Today we are going to go through kinematics. And what is kinematics about? Kinematics is all about your displacement, velocity, acceleration, time, speed, distance. If you learn in physics, you will know that kinematics is all about this. But in math, the only four things that you need to know, as you can see on my left hand side, we have our displacement, velocity, and acceleration. And also the most important thing is time, because time is a constant variable that is going throughout your displacement to velocity to acceleration. So if the question is going to give you time at a given time at a specific period of time, so you can use that specific period of time to solve this question. So kinematics, what we're going to do on this topic is that you need both your differentiation and your integration. You require the both knowledge, the both tools of them, and you're going to solve this topic on kinematics. So you cannot have one without it. You cannot know only differentiation and not integration, and you need the both knowledge to do this topic. So what is displacement? Okay, displacement is defined as the distance moved by a particle in a specific direction. And if you realize that in this topic, we are not talking about distance and speed because they are scalar quantity, which means they do not have a fixed direction. But in this case, in kinematics, in math, we are dealing with displacement, velocity, and acceleration. These three, they are your vector quantity, except for time. Time is scalar. So which means that displacement, velocity, and acceleration, these three, they have a fixed direction. They are going in a specific direction. Okay, let's remember that. Now, what is velocity? Velocity is like speed, but it's just that it has a direction, a fixed direction. So it's defined as the rate of change of displacement with respect to time. It can be positive or negative velocity. And if you listen closely, this velocity is defined as the rate of change of displacement with respect to time. This means that if I differentiate my displacement, I will get my velocity with respect to time. And now, what is acceleration? Acceleration can also be positive or negative. If it's positive acceleration, this means that it's going faster and faster. The thing is accelerating. If it's negative acceleration, or you get a negative value when you calculate for acceleration, you get a you get a deceleration, or the thing is going slower and slower. Okay, and acceleration is defined as the rate of change of velocity with respect to time. So this means that if you differentiate velocity, you get acceleration. Okay, so we're going to go through why is that so. So in order to understand, we need to draw a simple displacement time curve or graph. All right, S and T. And in, let's say if my displacement is increasing constantly, and if I'm going to find the gradient, I will use S divided by T, right? I will get the rise divided by run, so S divided by T, and this will get me the gradient for my displacement time graph. And if you realize that the gradient, displacement divided by time, that will get me my velocity. In this case, I'm differentiating my S with respect to time. So if I'm going to go from here to here, my displacement to V, S to V, all I need to do is ds over dt. Okay, so I'm going to change a little bit on the graph. I'm going to put my y-axis as my velocity, and that will get me my velocity time graph. And if I'm going to find the gradient, v over t, dv over dt in this case, I will get my gradient to be my acceleration. Okay, so if I'm going to differentiate this dv over dt, I am going to get my acceleration. So you cannot jump straight from displacement to acceleration. You got to bypass your velocity unless you second derivative, which means differentiate twice of your displacement, you'll get your acceleration as well. So in order to go back from acceleration back to velocity, from velocity back to displacement, we need to do integration. We need to integrate our acceleration. So if we integrate this, we get this, we're going to get back to our velocity. And the same thing happens to our velocity. If we want to get to displacement, all we need to do is to integrate my velocity. So if we integrate our velocity, we'll get displacement. So this topic is about moving from displacement to velocity to acceleration and around, going one big round. Or the question might give you velocity and you can integrate to find your displacement or differentiate to find your acceleration. So it depends on the question as well. So for the particle to be at the initial position or initial velocity, the time will be 0. So if the particles is at rest or stationary, this means the particle is not moving, the velocity will be at 0. And if the particles is at the fixed point, this means that the displacement is 0. If you have a maximum minimum displacement, this means that velocity is 0 because the gradient at the max and minimum displacement, the gradient is 0, so velocity is 0. And likewise for velocity, if the maximum and minimum velocity, the gradient at the max and minimum, the acceleration will be 0. So you need to take note of all this when the questions will include all these key points. So you need to know what is happening so that you can solve questions that deals with kinematics. For our first question, we are given with a particle moving in a straight line in such a way that after t seconds passing through our origin, we are given with a displacement. So we have as, I'm going to write down the equation for the displacement first. So the first thing to do, the question wants us to find in terms of t, the equation for our velocity and the equation for our acceleration. So as you know, as displacement, we're going to get to our velocity, then we're going to get to our acceleration. In order to do that, we have to differentiate it. We have to dv ds over dt. We got to differentiate, and then we're going to differentiate dv over dt to get our acceleration. So we just have to differentiate this. So when you differentiate your displacement, you're going to get 4 over t plus 2 square. And when you differentiate our velocity, you're going to get our acceleration to be this. And how we're going to do that? We're going to apply our chain rule here. From our displacement to our velocity and from our velocity to our acceleration. So for our next part of our question, we want to find time when the velocity of our particle is 0.25 meter per second. So we're going to use our velocity equation. We are given with the velocity. So we're going to use this equation. Okay, so we're going to write it down here, 0.25 equal to 4 over t plus 2 square. So we're going to solve this. You're going to just find the t. And because it's a quadratic equation, you have two of the value, t equal to 2 or t equal to minus 6. And you know time is not going to be negative, so we're going to reject this and we're going to accept 2 seconds. So for the last part of our question, we have to find the acceleration of the particle when it is 1 meter away from O, our origin. So we have 1 meter and that is the displacement. So we're going to use the displacement equation since we are given 1 meter. So I'm going to put it down here, 1 meter, okay, 1 meter, which is 2 minus 4 t plus 2. So you can see that time is the unknown. And time is something that we can transfer around with the equation into my velocity, into my acceleration. So since we want to find our acceleration, so we have to find the time first. So time, if you're going to solve this, you're going to solve that time is 2 seconds. And you're going to substitute this 2 seconds into here, our acceleration equation. So that you can find what is the acceleration when it is 1 meter away from O. So we're going to substitute this inside. So we have A equal to minus 8, 2 plus 2, cube. And if you press this in your calculator, you're going to get minus 1 over 8 meter per second square. For our second question, we have a particle moving in a straight line such that its displacement as meter from a fixed point A is given by an equation, the displacement equation, where time is in seconds after passing through A. So we're going to find the initial position of the particle. To do that, we have our displacement equation, so I'm going to write it down first. So we have S equal to 2t plus 3 sine 2t. So since it's at the initial position, I can safely say that my time is 0. So when t is 0, so all we need to do is to substitute the 0 inside the equation of displacement. So we'll get something like this. And you're going to press this in the calculator, you get 0. This means that the particles is initially at point A because displacement is 0. It's starting from point A. Okay, so that is for the first part of the question. For the second part of the question, we want to find the equation for velocity and acceleration. So to do that, we just have to differentiate my displacement 2 times. One time to get velocity, second time to get acceleration. So we're going to do that. I'm going to write it here. So if you're going to differentiate my displacement, we're going to get my velocity. So ds over dt, this will be 2 plus 6 cosine 2t. And we have our acceleration. If you're going to differentiate one more time, we have negative 12 sine 2t. Just take note, when you differentiate sine, you get cosine. And when you differentiate cosine, you get negative sine. That's how you get these two equations for my velocity and my acceleration. Now we are going to find the time at which the particle first comes to rest. When it's at rest, it means that velocity is 0, it's not moving. So we're going to use the equation for my velocity equation. So we're going to use this equation. So we're going to get my velocity to be 0. So we have something like this. And you can see there is only one unknown, which is my time. And if you're going to solve that, you're going to get cosine 2t equal to negative 1 over 3. Remember, this is trigo. Okay, so you're going to use the quadrant method. You're going to find what is time. But take note that when you cosine inverse to find your basic angle, always leave your calculator in radian mode. You're going to do it in degree mode, you realize that the number is very big. So you're going to use in radian mode and you get t equal to 0.955 seconds. For our third question, we have our stone that was initially at rest. It was thrown from the ground into the air. So it is rising at the velocity which is given to us, the equation, and we have the time in second. We are asked to find the maximum height reached by the stone. So we're going to find height, which is our displacement. So we're going to use our velocity equation and get us back to our displacement equation. To do that, you know, displacement, right? Displacement, we have S is to V. We differentiate from my displacement, we get into velocity. But in this case, we are given with velocity. We want to get back to our displacement. We have to integrate it. We have to integrate back to our displacement. So that's the first thing we got to do. But you got to read the question carefully because the stone was initially at rest. It means that when time was 0, displacement is 0. So we're going to take that down first. So you're going to read the question very, very closely because there's a lot of things inside there that you need to take note of. Even they don't give you numbers. So t is equal to 0, s is equal to 0. Right? When time is at 0 second, your displacement is at 0 meter. So we're going to now integrate my velocity. So we have something like this, right? We have our equation for our velocity. So when we integrate it, so we're going to integrate my velocity and we're going to get this. Okay, so we're going to get 40t minus 5t squared plus my constant. So like I said that we do not want our constant, so we have to take note of the question carefully because in the first sentence, it tells you that and time is at 0, displacement is also at 0. So we're going to substitute this into my displacement equation to get rid away of my constant, because if we have time and a constant, we are unable to solve what is time, or we are unable to solve what is displacement because we do not need the constant. The constant can be found at the start. So we're going to substitute this inside. So you get this at 0, right? So we get this at 0, and we're going to just put all the things inside there. T equal to 0, displacement is equal to 0. We're going to find what is C, and if you're going to solve this, you get your constant to be 0. This means that my displacement equation is 40t minus 5t squared. So we get our equation for my displacement. So like I said, that now the question is, before we're going to solve this, we are asked to find the maximum height reached by the stone. And there's another clue there. When the stone is at the peak of its height, we know that it's going to stop for a moment. That means that at maximum height, the velocity is 0. So we're going to take that into account. We're going to get my velocity is equal to 0, and at this point it's going to give me my maximum height, but we cannot substitute v equals 0 inside my displacement equation because we do not have v inside that. But we can do something to that. We can put it in here to find time, because time is a constant variable that we can move around it to my displacement equation. So we're going to put that inside. We have 0 equal to 40 minus 10t. We're going to solve for the time. You get 4 seconds. And once you get that, we're going to put it into our displacement equation. Okay, you're going to put it here, inside here, and there you go. At 4 seconds, the stone will reach the maximum height. So what is the maximum height? So we're going to substitute the 4 seconds inside the displacement equation. And there you go, you get your displacement to be 80 meters. This means that the maximum height reached by the stone is 80 meters. And for the second part of the question, they want me to find the values for T when the particles is 35 meters above the ground. So we're going to find T when the particle is 35 meters above the ground. 35 meters is the displacement, so we're going to use the displacement equation to straight away find my value of T. So we're going to put this down here. I'm going to write it here. So you have your 35, right? So we have our 35 meter. 35 is equal to 40t minus 5t squared. And you're going to move this around, you get a quadratic equation. You get something like this. And you're going to solve this, you get t is equal to 1 or 7. So this means that the particles is 35 meters above the ground when time is at 1 second, and during at 7 seconds the particles is 35 meters above the ground. Now a particle moves in a straight line so that t seconds after passing through a fixed point O, its velocity v cm per second. We have the equation for our velocity, and we know that the particles is going to come to an instantaneous rest at point P. We're going to find the time when it's resting momentarily. So to do that, we know that when it's resting momentarily, instantaneously at rest, our velocity is 0. So we have the velocity equation. Very nice. We can just use that, give our velocity to be 0, and we're going to find time. So we're going to write that down first. My equation for my velocity is this, right? So we're going to get that to be 0. So you just have to solve this quadratic equation, and you get two value of t. You get t equal minus 1 over 3. Reject this value because time cannot be negative, or you get t equal to 3 seconds. So this is the answer, 3 seconds when it's instantaneously at rest. Next, we want to find our acceleration of the particle at P. We know that at P, it took the particle 3 seconds. We want to find the acceleration, but we don't have the formula, but we can do so by differentiating our velocity. So we're going to differentiate our velocity. So you get acceleration to be 8 minus 6t, and substitute my 3 seconds inside there. We have 8 minus 6 times 3. That will get me my velocity, my acceleration, sorry, to be negative 10 cm per second square. Right, this means that the particles is slowing down, or the acceleration is going in the opposite direction. Okay, so acceleration of the particle at p is negative 10 cm per second square. So we're going to find the distance OP from the origin to point P, and that's the displacement of OP. So we're going to find the displacement of OP, and you know it took the particle to travel from O to P in 3 seconds. So 3 seconds, we're still using that. We're going to find the displacement first, but we do not have the equation for our displacement. We only have our velocity. So what we're going to do is to integrate my velocity equation to get back to my displacement equation. So we're going to do that. We're going to integrate this. So if we're going to integrate my velocity, we're going to get 4t squared minus t cubed plus 3t plus c, and this will get me my displacement equation. And you can see that is a constant there. I do not want my constant to be there. So you're going to look at the question closely and ask yourself, when time is at 0, which means at the initial position 0 second, is there any displacement? Did the question state any displacement? If it's not, then you can safely say that at time equal to 0 second, my displacement is also 0 cm in this case. So we're going to substitute 0 inside, 0, 0, 0. All my time and displacement going to be 0. Okay, we're going to find what is my constant, and you're going to substitute inside, you get my constant to be 0. So we do not have a constant, but do take note that not all the case that my constant will always be 0. Okay, so you got to read the question carefully. You're going to still do it. Do not just jump into conclusion that, okay, my constant is going to be 0, and that's it. You're going to get the wrong answer at the end of the day, and you're going to waste all your effort and time. So just take that down. That's very important. Just take note of it. So we have my constant to be 0 in this case. So we get our displacement equation to be this. So we're going to confirm that this is my displacement equation. And now, at time 3 seconds, it took the particle 3 seconds to reach from O to P. So we're going to put the 3 seconds inside. Okay, so we get our 3 seconds inside, and you get 18 cm. This means that OP is 18 cm. And the last part of the question, we are going to find the total distance traveled in the time interval. Be careful that they are not asking for displacement. In this case, they are asking for total distance from time 0 to 4 seconds. So we know that from 0 to 3 seconds, it travels 18 cm. But what about 4 seconds? So we're going to still use the formula for my displacement. And we're going to substitute a few values inside when t is 0 into my displacement equation. You get that your displacement is 0. When you substitute 3 inside, like what you did just now, you get 18, right? You get 18 cm. And now try to substitute 4 seconds inside, and you get that this is 12 cm. Okay, what does this mean? If you see that it is reduced it from the distance from at the time 3 seconds to 4 seconds, it reduced from 18 cm to 12 cm. This is a displacement equation. Is not talking about distance. So I'm going to draw the distance out for you to see. So we have our 0 mark here, and you know that this is 12 cm. And from here, the particles start from time 0, travel all the way here. Sorry, this is not 12 cm. I should take it as 18. Okay, so I have 18. So we know that it took the particles 3 seconds. And now the particles is going back because the displacement now is 12 seconds. From 0 to 12. So the particles have to go back. So the particle have to go back, have to reverse its direction. And then the displacement is true. At 4 seconds, at this place, t equal to 4 seconds, the displacement is 12 from the origin. Okay, so we're going to calculate the total distance traveled. So you can see very clearly from here we have my 18 cm from 0 to 3 seconds, plus we're going to add 6 cm. because that is from 3 seconds to 4 seconds, it traveled back 6 cm. That will get me a total of 24 cm total distance traveled by the particle. And now we are moving to our fifth question. We have a particle moving in a straight line, passes a fixed point O with a velocity of 4 meters per second. The acceleration formula is given to us. Okay, and we first want to find the value of time when the particles is instantaneously at rest, which means my velocity is 0. But we do not have our velocity equation. We only given with my acceleration equation. So what we're going to do, integrate my acceleration equation, and we're going to get our velocity equation. So the first step to do is to integrate it. So we have our acceleration equation. We're going to integrate this one to get me back into my velocity equation. So integration is much more trickier than differentiation because of the constant. So you're going to ask yourself, at time 0 second, what is my velocity in this case? In this case, they say it passes through the fixed point origin with the velocity 4 seconds. This means that at time 0, my velocity is 4. So I have 4 equal to 0 square minus 5 0 and plus c. We're going to find what is c, and c is 4. So we're going to put it back in the velocity equation. We're going to get this. Right, we got our velocity equation. But that's not the final answer, because we want to know the value of time when the particle is momentally at rest. So when it momentally at rest, this means my velocity must be 0, right? So we're going to put that into the equation. We're going to find what is my time. To do that, solve this quadratic equation. So once you solve this quadratic equation, you get two values, 1 or 4. There's nothing wrong with this. This means that when 1 second, the velocity is 0, and at 4 second, velocity is also at 0. So now for the last part of the question, we want to find the displacement of the particle when time is 2 seconds. It's not 1 second or 4 seconds. In this case, they're talking about when time is 2 seconds, when t is 2 seconds, what is the displacement? But do we have our displacement formula? No, right? We only have our acceleration, we found our velocity. So what we're going to do, we're going to integrate my velocity. We're going to get back to our displacement equation. So we got our velocity equation here. So we're going to integrate this. You will get something like this. Okay, so we have 5 over 2 t squared plus 4t plus d, another constant. So we're going to remove this constant. We're going to find this constant. We're going to have that constant with us. So you're going to ask yourself a few questions again. So at time 0, when time is 0, what is my displacement? Did they say anything about the displacement? No, it starts from 0 at the origin, right? So the displacement is also at 0. So you can substitute that into this equation and to find d, and you get your d to be 0. So therefore, we have our displacement equation to be this. So we have found our displacement equation. Now we need to find the displacement when time is 2 seconds. So we're going to just substitute 2 seconds inside this equation. So we're going to put 2 seconds into the equation to find our displacement when time is 2 seconds, right? So we're going to solve this. So we're going to press this in the calculator. Okay, sorry, this is 2 seconds, right? Then we're going to get our displacement to be 2 over 3 meters. And there you go, you found the displacement when the particles took 2 seconds to travel from point O. So we're going to go on with our last question. And for the previous question, if you're confused, or if you want, you can just rewind the video. You can try to understand, pause the video, take your time to read the question carefully, because by right now you have the rough idea on how kinematics works. So it's going to be tedious at first because it has a lot of information, but if you read the question carefully, you should be able to do it. So now we're going to go on with the last question, and we have this particle starts at rest from a fixed point O. Okay, it starts from a fixed point O, or origin, and travel in a straight line so that t second after passing through point O on the line, the acceleration is given by this equation. So we're going to find t when the particle first comes to rest, instantaneous rest. This means that we want to find my velocity first, right? We want to find the velocity equation, but we are given with my acceleration equation. So the first step to do, as usual, we're going to integrate my acceleration formula. So equation, I mean. So we're going to integrate this and we will get 2 sine t plus cosine t plus c. We have a constant again. So you're going to ask yourself, at time t, always ask this, at time equal to 0, what is your velocity? So my velocity is 0 because the question state that it starts from 0, right? From my origin. And it didn't state that at my origin does it have any velocity. So if it doesn't, means it's 0. So you're going to put it into this equation and you realize that you will find that your constant is -1. Put it back into the equation, we get my sine t plus cosine t minus 1. So this is my velocity equation. And we want to know that at instantaneous rest, this means that my velocity is at 0. So my velocity is at 0. So v is equal to 0. Put it into the equation. Find t. Solve for t. So when you're going to solve for t, this is going to be a little bit more trickier than the previous question. You get something like this. 2 sine t plus cosine t equal to 1, right? And what you're going to do is you're going to use the R formula to solve this. So the R formula, we have square root 5 sine. So you're going to find your alpha from here equal to 1. Okay, so you got to remember how to find this. To find square root 5, just take 2 square plus 1 square, then you square root, you get square root 5. And to find the 0.4636, just tangent inverse 1 over 2 in radian mode. Okay, remember, you always solve kinematics question in radian mode. So once you get this, find t. Use the quadrant method, find the basic angle, and you get time to be 0.4636. Sorry, this is not time yet. Okay, you're gonna get t plus 0.4636 equal to 0.4636 and 2.677. And if you're going to find your time, you get 0 and 2.21. So the particle come at an instantaneous rest at these two timings, 0 second and 2.21 second. 0 second definitely because it's not moving at all, it's at the origin. So we're going to say that therefore time is 2.21 second when it comes to an instantaneous rest. Now we are down to our last question. You're going to find the distance traveled by the particle in the first 3 seconds after leaving O. You can let t be 0, t be 1, t be 2, but it's up to 3 seconds. But we do not have our displacement equation. We have our velocity and we have our acceleration. So we're going to integrate our velocity back to our displacement equation. So we're going to integrate my velocity. So when you integrate this velocity, we have our velocity here. Right, we're going to integrate it. And that will give me s is equal to sine t minus 2 cosine t minus t plus d. So we have our constant again. So you can see here I have integrated. So to find the constant, just ask yourself this question again. When time is 0, what is my displacement? It should be 0 because the question states that it starts from our origin when time is 0. So when you substitute these two values inside to find my constant d, you'll find that d is 2. You substitute back the d inside the equation to get you the correct equation for displacement. You get this, and now they say they want up to 3 seconds. So you're going to substitute some value inside my t. So when time is 0, we know that displacement is 0. When time is 2.214, put it inside, you get your displacement to be 1.785, and when time is 3 seconds, because we want up to 3 seconds, when time is 3 seconds, we get our displacement to be 1.121. And realize the same thing, the drop in here to here again. Okay, now we're going to draw the distance line. So at time 0, we have 1.785 to be the max, and we have 1.12 in the middle there. So the first thing at 0 second, the time here at 0, t equal to 0, it travels through here first to reach, when time is 2.214, it reached 1.785. Okay, 1.785 meter. Then it U-turn back, it reverses its direction. So it's going to reverse back to here, my displacement to be 1.12. And this will be my time to be 3 seconds. And you're going to just find the distance. You're going to add all this thing up. You get 1.785 plus 1.785 minus 1.121. And you're going to add this up together. You get 2.45 meter. So this is the answer, 2.45 meter, when the particle take from 0 second all the way to 3 seconds, the total distance covered.